let's dive right into this explainer and look at a really fascinating new architecture called Nemori. What we're doing here is walking through exactly how Nemori transforms those chaotic, raw message buffers into clean, structured, episodic memories for AI agents. It's heavily inspired by human cognitive science, and it's designed to finally give our artificial companions a true sense of lived experience. Right off the bat, we have to tackle a universally frustrating problem: AI amnesia. You know the feeling. You start a new session and the bot greets you like a total stranger, completely forgetting everything you talked about yesterday. Now, underneath the hood, large language models have a fundamental constraint. Their context window is limited by what researchers call quadratic attention complexity. And hey, even if you throw a massive context window at them, they suffer from this thing called the lost in the middle phenomenon, where they just failed to use information that's buried deep in a long conversation. Sure, they can fake personalization for a single chat, but without a structured memory system, that illusion completely shatters the second you close the window. So here is the absolute core of what Nemori does. The entire architecture is built to give the agent a way to say, this part of the conversation belongs together as one experience. Instead of treating memory as this static library of random facts that it just blindly pulls from, Nemori treats it like a dynamic, self-organizing diary. It basically gives the AI the cognitive ability to look at an ongoing, messy dialogue and definitively say, okay, these specific messages represent one complete, self-contained event. Okay, let's jump into section 1, the AI memory problem. Before we get into the fix, we really need to understand why standard memory systems fail. You might be wondering, wait, don't we already have systems like RAG to solve this? Well, the problem is that standard RAG arbitrarily takes scissors to the conversation log. It completely breaks the logical flow. Imagine you're chatting with an AI. You ask about the color of an apple, you get a response, and then you say you love it. Traditional RAG chunks data by fixed sizes, so it literally draws a hard, arbitrary line right through the middle of that thought process, completely separating the context of the apple from the AI's follow-up that it's very healthy. The memory is just severed. But with an episodic approach, the system actually groups that entire discussion into one unbroken boundary. And that's the real issue. Standard chunking destroys contextual meaning. Because traditional systems chunk by a fixed size or by strict interaction pairs, they lose the rich, overarching narrative of the discussion. Researchers actually call this the granularity gap. If you just grab raw text arbitrarily, you inherently lose all the social and contextual reasoning of the interaction. You don't get a memory, you just get these fragmented, stateless patches of information.
Moving on to Section 2, the dual pillar framework.
To solve that granularity gap, Nemori completely rethinks the architecture from the ground up, using a framework deeply rooted in human cognitive science. Specifically, it's based on complementary learning systems theory. Think about how your own brain works. We have fast learning systems for vivid, episodic details, like remembering exactly what you ate for breakfast this morning. And then we have slow learning systems for abstracted semantic knowledge, like knowing generally that eggs are a breakfast food. Nemori actually replicates this exact dual structure, allowing the AI to autonomously organize its own experiences just like we do. So, how do we actually create these meaningful memory chunks? Nemori uses a two-step process called the two-step alignment principle. First is boundary alignment, and second is representation alignment. This top-down method is inspired by event segmentation theory. It basically stops the AI from relying on lazy, arbitrary character limits and forces it to evaluate the actual semantic meaning of the conversation stream. Let's break that down. Section 3, spotting conversation boundaries. We'll start with boundary alignment, which is where the magic of converting messy logs into structured chunks really begins. Picture a massive, endless whiteboard completely covered in an unorganized, chaotic stream of user and assistant messages. That is your raw message buffer. Inside the system, it's just this accumulating sequence. It tracks the role of the speaker, the message content, and the exact timestamp. And it just keeps flowing endlessly as you type. Now, here's where it gets really interesting. Nemori uses an intelligent boundary detector to watch that endless stream, and it draws a clean line exactly when it identifies a shift in the conversation topic. Every single time a new message comes in, an LLM-based detector evaluates if a meaningful shift happened. What's it looking for? Things like a drop in contextual coherence, or temporal markers, like if you suddenly say, by the way, which usually means you're changing the subject, or a clear shift in user intent, like moving from just asking questions to making a final decision. It actually outputs a Boolean decision and a confidence score, so it knows exactly when a topic has ended. The end result is that it transforms an arbitrary, messy flow of text into a semantically meaningful chunk of experience. Nothing important gets cut in half. The system literally holds off on saving anything to memory
until a high-confidence semantic shift is detected, or until a predefined maximum buffer size is reached. So you get perfectly isolated moments of conversation that make total logical sense on their own.
Next up, Section 4, generating episodic memories. Okay, so once we have that bounded chunk, we enter Step 2, representation alignment. We have the exact messages, right? But raw dialogue is still way too messy for good long-term recall. So Nemori's episode generator reframes that raw dialogue block into a beautifully structured episodic memory. It generates a concise title and a rich third-person narrative summary. It basically acts as the narrator of its own life. Instead of saving a robotic transcript of user said X, assistant said Y, it creates a clean title that captures the core theme and a story that preserves all the salient details. And honestly, this perfectly aligns with how we naturally narrate our own past experiences to make them easier to remember later.
Which brings us to Section 5, better recall, better agents.
Why does any of this matter? Why go through the trouble of grouping messages by topic into these clean episodes? Well, it completely changes the game for complex reasoning tasks. By maintaining the natural narrative of the event, Nemori turns really difficult reasoning tasks into simple, highly accurate information retrieval. Think about a temporal reasoning question. Say a user mentions, John received mentorship yesterday. If the AI needs to recall that weeks later, a standard system gets incredibly confused by the word yesterday pulled out of its original context. But Nemori's episodic grouping has already processed that timeline into a clean memory chunk, perfectly preserving the exact chronological sequence of events. And the efficiency here is wild. We're talking about an 88% token reduction. Instead of forcing the AI to read through massive 23,000 token conversation histories every time you ask a question, Nemori provides perfectly tailored context using only about 2,700 tokens. Because it did the hard work up front, spotting the boundaries and writing the episodes, it only retrieves the exact relevant memories. This massive reduction in context size obviously saves computing power, but more importantly, it heavily reduces that lost-in-the-middle hallucination risk we talked about earlier. The results absolutely speak for themselves. When researchers tested temporal reasoning using GPT-4o, Mini providing the entire raw, messy context only yielded a score of 0.562, but when they used Nemori's highly structured episodic memory chunks, that score skyrocketed to 0.710. It is definitive proof that throwing massive amounts of raw data at an AI is vastly inferior to feeding it a highly organized, cognitively aligned memory structure. All of this leaves us with a really fascinating thought. As AI transitions from processing messy logs to forming structured, human-like memory, we are getting incredibly close to agents that can truly grow with us over a lifetime. I mean, if a machine can definitively say, this sequence of events belongs together, if it can narrate its own past, and if it can pull exactly the right memory at exactly the right time with pinpoint accuracy, well, we're no longer just interacting with a text predictor. We're interacting with an entity that has its own timeline, and that entirely changes the future of autonomous agents.